Hello everyone, good evening.
Good evening, sir.
Good evening, sir.
Good evening.
So, how's the result for quiz 2, everyone? How was
Decent,
the
sir.
quiz 2 result? Okay. Uh, okay, so let's start with week 10 solve with us. So, have you guys covered the content of week 10?
Yes, sir.
Yes, sir.
All the lectures? Huh?
Yes, sir.
Okay, great. Okay, so I think by now you all are aware of instructions. Just go to joinpd.com and enter the code shown on the right top of your screen, which is BUGFBU. And for every question, you will get 5 to 10 minutes. You can answer to these questions on this joinpd.com and keep a notebook and pen along with you so you can solve the questions within the time limits. Okay. Yes,
So,
those who are yeah.
so please cover that hypergeometric random variable yes,
Yeah, we will cover it. It will be covered in these slides.
because I can't understand it fully.
Yeah, we will do it. Okay, so those who are using it on laptop or desktop will have the view as shown in the left side of your screen, and those who are using it on mobile will have the view as shown in the right side of your screen. And mobile users have to click on the button answer question and then input your answer, while laptop or desktop user can input it side by side while seeing the question. Okay, so let's move to our first question for now. So there's a box which has some balls numbered 1, 2, 3, 4, and the probability that you will draw a ball which has the number 1, 2, 3, or 4 is proportional to that number on the ball. Okay, so if one ball is drawn at random from the box, then what is the expectation of number on the ball drawn? Is the question clear to you guys? Like from week 9 you are able to understand your undersign random variable to such events. Is it clear or any doubt in this?
How is it proportional directly or inversely?
It's directly. Whenever it's inverse proportional, it would be mentioned. If it's proportional, it means it is just like you will find the value of proportional constant, right? So if you take it inversely proportional, you will get some different value for that constant. If you take it directly proportional, you will get some different value for constant. But at the end, you will get the same answer. So it doesn't matter which proportional you take. So are you guys able to understand and assign random variables to this event by now?
Uh, is there a number on the ball? Is there any number of the balls?
You don't know about how many balls are there. You just know that there are balls numbered 1, 2, 3, 4, and the probability of drawing the ball is proportional to that number on the ball. That's the only information you have. Done with this or need more time to solve this one?
Done, sir.
Okay, so let's move to the solution part before that. Okay. Okay, so you were able to assign the random variable, like what is your random variable, what will it denote, and what are the possible values it can take?
Yes, sir.
Okay, anyone
What?
just
1, 2, 3.
Probably that the ball is number one, probably that the ball is number two. P of x is equal to 1, P of x is equal to 2,
Let-
P of x is equal to 3,
no,
and
no,
P of
what
x.
what is your random variable? What will it represent over here? What is x over here? You said x equal 1, x equal 2. What is x?
Number
Number of
The
balls.
number on the ball.
Number on the ball.
Number on the ball, right?
Yes,
Yeah.
sir.
So, and the possible values it can take is 1, 2, 3, and 4, right?
Yes, sir.
Yes.
And let k be my proportionality constant, and we know that its probability is proportional to the number on the ball, right?
Yes, sir.
So for x equal to 1, the probability that my random variable x will take the value 1, it's 1 times k, right?
Yes, sir.
Similarly for 2, it's 2 times k. Similarly for 3 and 4, it 3 times k and 4 times k respectively, right? Is this PMF table clear?
Yes, sir.
Can we take total balls as Q?
Total
Total number of balls in the basket as Q?
number of balls in the basket. Yeah, you can take. It will give you the same answer. Okay, so yeah, we know that total sum of probabilities is 1. So all these 4 values should add up to 1, right? So from this equation, we can find the value of k, which comes out to be 0.1 or 1 over 10, right? Were you able to do it till this step?
Yes, sir.
Okay, so once you have the value of k, it means you know all the 4 probabilities, right? And you can simply plug in the formula of expectation to compute it, which is nothing but summing over all values of x, the product of x times its probability, right?
Got it, sir.
Yes, sir.
Anyone any doubt in this before we proceed further?
No, sir.
Okay, so second question is also it's linked with the previous one. It's again the same description. You have the box of numbered balls. Balls are numbered 1, 2, 3, and 4, and the probability of drawing a ball is proportional to the number on that ball. But this time we are drawing 3 balls with replacement. So you have to find what is the expectation of sum of numbers on the ball drawn. So this time instead of 1 ball, we are drawing 3 balls. So what would be the expected number, sum of numbers on the 3 balls we have drawn?
Sir, I had doubt in the first question. Could you please go on the first question?
Okay, what's your doubt?
Sir, about that line, wait. The probability of drawing the ball is proportional to the number of the ball. Like
Yeah,
I did not get what does this line mean. Like how did you use this line in the earlier answer?
how did we do this line? Okay,
How,
so you
like
know
what
proportionality
information?
constant.
Yes,
Okay, so
sum of all the proportionality is always equal to one. That property, right?
no, the proportionality constant. Okay, if I'm saying that probability my random variable x will take some value small x is proportional to small x, right? You know this, right? That's what that line means. So by using the proportionality constant, I can write it as k times x, right? So here this
Okay,
k is
yes,
my
you introduce the
propor-
constant.
proportionality constant, right?
Yes.
So now my x takes the possible values 1, 2, 3 and 4, right? So
Yes, sir.
probability x equal x is k into 1, right? Kx,
Okay, okay.
k into 2, k into 3, k into 4, right?
Yes.
Secondly, I know that sum of these probability should be 1, because if I add up all these probability of all the possible values of random variable, it should add up to 1, right?
Yes.
So it is 1. So on solving, I can get the value of k, which is 1 over 10, right?
Okay, okay. K equal to 0.1.
Once I have the value of k, it means I can have all this probability, right? So after that, you can compute expectation, right? You know its formula.
Okay, yeah, thank you, sir.
Sir, I directly taken the values of 1 by 10, 2 by 10, then I add all of them. So is that possible?
Yeah, in this case, it's yeah, you can do that. I think that will always work. Yeah, that would also work. Okay, but it's just better to check if the sum is coming out to be 1.
Yes, sir.
Okay, I will extend the timer for this question, so you can do it. Are you able to do it, or you still need more time to solve it?
Doing, sir.
Okay, I will extend the timer. Done now, or still need more time? Okay, let's move to solution part. Case. Okay, so how did you guys approach this one? Like, what was your starting? How did you start to solve this one?
I tried writing down all the combinations for some.
All
So
the
for 3 we
combinations.
so
Okay.
for 3 we get 111. For 4 we get 112.
Okay.
For 5 we get 122. No other combination is possible among 3 numbers.
Yeah.
Then for 6 I got 2 combinations, 222 and 123.
But 1, 2, 3 can also interchange
3 to 1.
in between, right?
It doesn't
Yes.
matter, right? We need to. It's 2 by 6, right? 2 by 10.
Okay, but if you are getting 1, 2, 3 or 3 to 1, these two are different outcomes, right? You need to take it
Okay.
into consideration while computing probability.
Okay.
Okay, so did you all did the same way, or anyone
No,
had some
no,
different
sir.
approach?
No, sir. I have taken like when the sum is 3,
Yeah,
we have only one possibility, 111,
right.
and it's going to be 1 by 4 cube.
Okay.
If it is 4,
Mhm.
the possibilities are 112, and they can be arranged among themselves. That is 3 factorial by 2 factorial, 3 ways.
Okay, but in total, if you look at it, there are 4 cube possibilities, right?
Yes, sir. That is our denominator.
So if you write it, it's gonna be something, I think, around 256 cases you need to make, right?
Yes, sir. That's where in between I was stuck, sir.
So we
Okay.
can also look at it like for the first picking, the expected value is 3. For the
Yeah.
second pick, it is again 3, and for the third, it is again 3. So it is like E of x is equal to E of x1 plus x2 plus x3.
Yeah.
And we can write this as 3 times E of x1, which is 3 into 3, which is 9.
Yeah, that's a better approach. See, so how did he approach this? He assumed that x1 be the number on the first ball drawn, right? X2 be the number on the second ball, and x3 be the number on the third ball. Okay. So we need to find the expectation of sum. So let x be the sum of number on the 3 balls. So in general, you can write this sum as x1 plus x2 plus x3, right? And we need to find the expectation of it. So expectation of x is nothing but expectation of x1 plus x2 plus x3. Now, do you all know the property of expectation?
Yes, so this.
For independent events, it's a sum of
Yes, sir. Yes, sir.
individual expectations.
Right? these all are independent, right? Because it's with replacement. So for each ball, you have the same possibility for each of the number. Like even if I draw number 2 on my first draw, it is not affecting the probability in my second and third draw, because again in the second draw I have all the balls placed back in the ball before drawing, right? So it's 3 plus 3 plus 3, which is 9. Is this approach clear?
Sir, clear.
Okay. You can also go by, yeah.
I can't understand this x1, x2, x3. Means
Which part?
drawing 4 dots. Right?
We are drawing
In
3
the-
balls.
3 balls is there the question. Means how to find the probability in x1. That's what I can't understand.
This expectation of x1.
No, expectation is calculated in the previous questions. And
Yeah.
that I have understood. This x1, for every x1, we were defining some p(x1). So how to define probability in this?
How to define probabilities? Okay, so let's see. In the first question, you have this PMF, right? This one, this table, right? It for the first draw, you know that probability of drawing ball numbered 1 is 0.1. For 2, it's 0.2. For 3 and 4, it's 0.3 and 0.4 respectively, right?
Yes.
Once I draw the ball, I noted the number and put it back in the box, because we are drawing the balls with replacement, right?
Yes.
In the second draw, it would be the same probabilities, because it's again the same box you are drawing from with all the balls in it, right?
Yes.
So again for second draw, the expected value would be again 3, and it would be the again same PMF for x2. Similarly for x3, it would be the same PMF as x1, because we are doing it with replacement. So
Okay,
expectation would be same for all 3, and PMF would be the same too.
Sir, what will be the answer if it is without replacement?
If it's without replacement, in that case, you might have the count of total balls, and probability will keeps on changing. I think you need to take the question would be framed in such a way that you would be able to find out these factors. In such case, we don't know total number of balls, so it would be a bit of complicated one, right? So in case of without replacement, see, whenever we are drawing 3, 4, any number of balls, you can try to split it into smaller random variables. Like here for 3 balls, we split our main random variable, which is sum of number, into 3 smaller ones, right? Number on the first ball, number on the second ball, and number on the third ball. If we add these 3, I can simply get the sum. So the major thing you need to tackle is just try to break it down into smaller parts and then try to solve it, right? So yeah, that's the solution part. Xi be the expectation of the number on the ith ball drawn. So expectation of Xi is 3, we have already computed, and Y is the sum of numbers on the ball drawn, which is nothing but x1 plus x2 plus x3, which is nothing but 3 times 3, 9. Any doubt in this one? Anyone? Or shall we proceed further?
It is clear.
Clear. Okay. Okay, moving further. Okay, so quiz 2 result you all know has been declared, and EMQ may have benefited some of you in some sense. So what's your thought on this? Let's just quickly do it, so that we can include it in further quizzes as well if you like this pattern. Just a feedback, so you can be honest with it.
So is it a question?
Yeah, just simply a feedback question on quiz 2. The result is declared, right? You have seen your marks, you are aware of it. So there were EMQ question as well if you're aware of it.
What full marks allotment in that question?
No, if the NAT was of 3 marks, you would have got 1 mark in the optional question. If the NAT was of 4 or 5 marks, you would have got 2 marks for the optional question. Okay, we have the responses. Just another, if anyone, any other suggestion or something, or any other comments, or any improvement you would like to have in it, just simply write it, please.
Make all questions options, sir. If there were options like my, I would have made a couple of mistakes.
Yeah, we are working on it. It's still in experiment phase, so it's we
No,
started it only week 5, 6.
so
Yeah.
the thing is, right, I calculated probability for combinations. I did the entire combinations and then I calculated the probability as well. And then I answered probability. If there were only 4 combination options, right, I would, I wouldn't have done the probability part.
Okay, yeah. Mhm. Yes. So this is the purpose for this. Even if you know concept, you sometimes still answer wrong, right?
Yeah, that's true.
So instead, you won't be losing complete marks. It's just you can have it. So it's better if you all provide your feedbacks over it for improvements. Okay, so yeah, let's move further to our next question. So our x is a random variable with the PMF as shown in the table. So a random variable x can take possible values -1, 0, 1, and 2, and the probabilities are 0.1, 0.15, 0.3, and 0.45 respectively, right? Now I want to transform this random variable x to some g of x, and that function g of x is defined as x squared plus 3. So you need to find what is would be the expectation of this function g of x. So first step would be you should try to obtain the PMF of this g of x and then try to find its expectation. Are you able to do it or still need more time?
No, sir. It is quite easy.
Done, sir.
Done, sir.
Okay, so let's move to the solution part. Okay, so we know that x can take value -1, 0, 1, and 2, right? So in that case, what all the possible values our function g of x will take? If x is -1, then g of x will become 4, right? If x is 0, then g of 0 would be 3. If x is 1, then again our g of 1 will become 4. And if x is 2, then again g of 2 will become 7, right? So in general, if you noted the possible values that g of x can take is 3, 4, and 7. Is it clear till this step? Or any doubt in this?
No doubts.
Okay, so now let's assign probability to it. So my gx will take the value 3 when x takes the value 0, right? And what is the probability of x taking the value 0? It's 0.15, right? Now when will my gx will take the value 4? When my x is either equal to -1 or x equal to 1, right? So probability that gx will take the value 4 is nothing but probability x equals 1 plus probability x equals -1, which is nothing but 0.1 plus 0.3, which is 0.4. Is this thing clear? Similarly, for gx will take the value 7 when x equals 2, and we know its probability is 0.45. And then simply when you know that you know possible value that gx can take, and you also know the probabilities with which it can take these values, you can simply compute the expectation, right? Or any doubt in this?
Sir, I took it a slightly different approach.
Yeah, you
What
can
I
do it.
calculated is x square and then multiplied directly with the probability and added 3 to the end result.
Yeah,
I
yeah,
got the
that's
same
also you
answer.
can do it. Yeah, you will get the same. There are different ways you can approach. You can simply compute expected value of x square and then add the constant 3 to it. So it's just how you use the property of expectation in different ways, right?
Got you, sir. Yeah.
Sir,
Yeah.
in this I had some conceptual doubt that how probability doesn't differ by change of functions.
Okay, why would it differ? See, your gx will it take the value 3. When will it take the value 3?
When x equal to 0.
X equal to 0. And then with what probability x would be 0,
It is given at 0.15.
right? Similarly, when would gx be 4? When my x takes the value either -1 or 1, right? What is the probability of x taking the value -1 or 1? It's the sum of 2, right? So that's why even if we are transforming it, in general depends on the initial values only. That's why probability remains the same even if you change the function.
Hello, sir.
Clear, right?
Hello,
Yeah.
Yes.
sir. What does x equals to -1 means? Yes, x equals to 1, I understand, but what -1 means?
When see, we know that x can take the value -1 as well, right? So when x is -1, our function gx would become -1 squared plus 3. So if x equals -1 means g of x would take the value 4, right? Similarly, when x is 1, g of x will take the value 4. So in what cases my gx would be 4? When x equals -1 or x equals 1, right?
Yeah.
So probability of gs taking the value 4 is same as probabilities of x taking the value either 1 or -1, right? So we can simply add these two, 0.1 plus 0.3.
Thank you, sir.
Clear now, everyone?
So what was the other approach you talked about?
Other approach is instead of computing complete gx, what you can do is, you know x, right? -1, 0, 1, and 2. You know its probability, right?
0.1, 0.0, 0.3, 0.25.
So you can compute expected value of x square,
Yes,
which
sir.
is nothing but summing over all values of x square into probability, x equals x, right?
Yes, sir.
You can compute this value, but you need to find the expected value of x square plus 3. So we know that by property of expectation, I can write it as this. Adding a constant, you can take it outside the expected value, right? It
9.
would be simply this plus 3.
It will be 4x square plus 3 plus 4x also.
Plus 4xy.
So because you're checking for the
That is not a plus b
No,
whole
no, no,
square.
no. Okay.
It's not a plus b whole square, it's x square
It's
plus.
only 4x
It's
square
simply
plus
expected value of x. You can simply write it as expected value of x square plus expected value of 3. And we know expected value of constant is same as constant, right?
3. Yes.
So you can write it. So you can also, another approach is you can compute expected value of x square and then plug in the values here to compute it.
Okay. I made mistake here.
Is this clear?
Yeah. Now it is clear.
Okay, let's move
I thought
further.
that was the whole
Yeah.
raised to power square. So that's why I
No,
said 4.
yeah, this thing needs to be taken off care of. Many
Yeah.
people make this mistake. Okay. Okay, moving further. Okay, so this is the hypergeometric distribution someone was mentioning in the beginning of session. So you have a box and there are 10 chocolates in it. 6 are milk chocolates and remaining 4 are dark chocolates. Now we are drawing 2 chocolates at random without replacement. Okay, keep this thing in mind that we are drawing without replacement. Now you need to find the probability that one dark chocolate is drawn among those 2 randomly drawn chocolates. So
So do.
yeah, in general, you are drawing 2 chocolates from this box of 10 chocolate. You need to find the probability that you get one dark chocolate and one milk chocolate, right?
Okay. Then okay.
Okay, is this done or you need more time? Anyone need more time or sure?
A few
That's
seconds more. A few seconds more.
Okay, okay.
Sir, I think similar question was there in quiz 2. A bit change in that.
In quiz 2. Okay. Check.
Yes, sir.
Okay, yeah, that's from week 7 or 8, 7, right? This now we are doing similar questions with the random variables in some easy approaches. Okay. Firstly, do you all know what is hypergeometric distribution?
Yes, sir.
Please
So-
repeat it.
Yeah. Okay. So what? Suppose this is my complete population. Okay. This is my complete population, and within my population, I can split it into two parts. Okay. Suppose in this question, my population was box of chocolate, right? And I can split it into two parts. One is dark chocolate and one is milk chocolate, right?
Yes, sir.
And let's say these are so there are small m chocolates over there, right? And remaining n minus m are over there. Okay. So of these 10 chocolates, we are taking a small sample, right? We are drawing small n elements without replacement, right? So of this complete box of chocolate, we have divided it into two parts. One is dark chocolate and other one is milk chocolate. Now we are drawing two chocolates without replacement. So our n is taking value 2 over here. And now you need to find the number of, the out of these drawn elements, how many elements belong to one specific category. Like here we are interested in the number of dark chocolates, right? Let's say x is number of dark chocolates. So what all possible values your random variable x can take? Either 0 dark chocolates are drawn, or 1 dark chocolate is drawn, or both of the drawn are dark chocolates, right?
Yes, sir.
But our question asks is that one among the two drawn is dark chocolate. So we are interested in probability that x takes the value 1, right? So in general, if you will see it is, out of total 10, we are drawing 2 balls, right? 2 chocolates. Out of my complete population of 10 chocolates, I am drawing 2, right? So in total, I can draw 10C2. There are 10C2 ways to draw 2 chocolates, right?
Yes, sir.
10C2. Now, one condition is that there should be 1 dark chocolate. So we know that there are 4 dark chocolates in there, right? And we need to draw 1. So 4C1 to choose 1 dark chocolate. And of the remaining 6, right? 10 minus 4. We need 1 more. So 6C1. We need 1 dark chocolate. It means the other should be the milk one. And total weight is 10C2. So this is nothing but hypergeometric distribution. Whenever you can divide your population into 2 parts, and then you are drawing without replacement, you can simply use hypergeometric distribution. And our major interest is in the number of outcomes from a specific category. Like here, we are interested in number of dark chocolates. We are interested in this portion of our population, right? Any doubt in this, anyone, or is it clear?
So, but
Yes, sir.
this
Small
question
doubt, sir.
doesn't even require
This question?
this question doesn't does not require this distribution. So can it be more refined? Like where is it particularly useful?
In this question, it requires hypergeometric distribution. It is hypergeometric distribution in general. Okay.
No, but I directly solved using 4C1, multiple 6C1, using
Yeah, that's what
permutation.
you do. Yeah, but see, you have done this question in week 6, 7, 8, right? You have done similar questions. You have done
Yes.
using permutation combination, but now you are getting to know the names. You have done a lot of question, but you are not aware of which distribution you have used. So this is hypergeometric distribution. And when we do with replacement instead of without, that would be binomial distribution. You will study it in week 11. So you have done already these things. Now we are just doing the same things, assigning random variables to it. You haven't used random variables till week 8, right? We will do the same questions. This is the same type of question, but this time we will assign random variables. Okay, so you are saying that you can simply do it by permutation combination, right? But if I ask you to compute the expected value of x, in that case, you will have to compute probability x equals 0, x equals 1, and x equals 2, right? You need to compute all these three. And then multiply it by 0, multiply it by 1, multiply it by 2 to compute the expectation, right? But when I know that it is hypergeometric distribution, then we can simply use the formula of expected value for hypergeometric distribution. We don't need to do this extended calculation. I can simply use the formula and get the value. So that's how random variable and distribution is going to make a lot of things easier for you.
I mean by capital N, no, sir?
Yes, sir. The bottom was the capital N.
Capital, yeah. And by capital. Is this clear?
Yes.
Or any doubt in it, anyone?
No, sir.
In previous question, this question, sir, one dark chocolate is asked. So I did 4 by 10 into 6 by 9. But I couldn't understand why we have to multiply it 2 times. Because dark and milk and dark both are different now, sir.
Yeah, so you have considered only one case, right? You first drawn dark and then milk. But it is also possible that you first draw milk, then draw dark. So in that case, it would be 6 by 10 for milk and 4 by 9.
4 by 9. Yeah, I did like this, sir. I got it.
You need to take both. See,
Plus.
Similar question we have done in week 7, 8. But
Yes,
how hypergeometric distribution making
is
easy, right?
Yeah. And now we got it.
So, in stats 2 also you will be using only random variables. You won't be doing question like permutation combination. Those are just the basic things. Everything you have done right now in the basics. Now the major focus is to make things easy, right? And
Sir,
Sir,
if the question would be like find the probability that at least one of the chocolate drawn among two is dark chocolate. If the condition was at least one, then how would you approach it?
1 minus 0. 1 minus probability x equals 0.
So we will find the probability of dark chocolate, like probability of 0 dark chocolate, and subtract it from my 1, right?
Yeah, that would be the easiest way. You can also do it x equals 1 plus x equals 2. But whenever at least one comes, I approach this way. That makes the things a lot of simpler.
Okay.
And yeah, one more thing is for this end term, week 1 to 8 is gonna be close to 25-30%. Remaining 9 to 12 will get 70% weightage. So you have to work on random variables to pass the end term exam for sure. Random variable and conditional probabilities is gonna be the major topics. Okay. Any doubt in this question till now, anyone?
Done, sir.
And hypergeometric distribution is clear, right?
Yes, sir.
So what is this distribution? This writing notation like 4, 1, 2, 6, 1, 20.
This is 4C1. Yeah, another way to write it is like that. In some books, you will find it written like that. It's same. It means 4C1. It means 6C1. It means 10C2. It's the same way. Okay. Okay. This question I think we have already discussed. Just you can quickly answer. What is the expected number of dark chocolates drawn? See, so if you go by week 7-8 approach, you have to compute the probabilities for all three. But you know now that it is hypergeometric distribution, you are able to identify by reading this context. This question becomes very time saving for you guys, right?
Sir, how we solve with this hypergeometric random variable approach?
So-
For this small n become 2.
Yeah,
And-
what is small n? Small n,
how many chocolate we are choosing?
that small n. Okay, let me clarify some terms. Firstly, okay, first a minute. Yeah, see, in our population, we assume that there are capital N elements. Okay, this is my population size, right? Now we are dividing it into two parts. One is dark chocolate and one is milk, right?
Yes, sir.
Okay, so we are interested in dark chocolates, right? So assume
Yes,
that
sir.
small m chocolates are dark and remaining capital N minus m are milk. Okay, now out of
Yes,
these we are drawing small n elements. This is my sample size, right?
Yes, sir.
So I need to identify how many dark chocolates would be there in my sample. So excess number of dark chocolates, right? So your m is the number of elements in your population of your favorite category, the category you are interested in. Here we are interested in dark chocolates, right?
Yes, sir.
So the small m is that thing. Capital N is total number of elements in my complete population, and small n is the how many chocolates I am drawing, but it's my sample size, how many elements I'm drawing from this, right?
Sir, in this question, we are drawing 2 chocolate, but condition is 1 dark chocolate. So, what effect in on hypergeometric random variable approach? We divide by 2, or
No. Here we are not drawing one chocolate. Here question says that what is the expected number of dark chocolates drawn?
okay, sir.
Okay, so previously it was probability that x equals 1, right? 1 dark chocolate. But here you have to compute the expected value.
Okay.
Clear, right? Or any doubt in this still?
Yes, sir, clear.
Okay. Sending the timer by 1 minute so you all can now answer it simply.
So here we have to consider only 2 chocolates are drawn, sir.
Yeah, 2 chocolates are drawn
Sorry,
at
sir, sorry.
random
Okay,
without
it's
placement. Yeah, it's fine. Done everyone or need more time?
Done, sir.
Okay.
Done, sir.
So here you
Done,
are
sir.
able to identify the values of small m, small n, capital N, right?
Yes, sir.
Okay. So here small m is the number of, okay, I think we have interchanged it. So yeah, small m is the number of dark chocolates in the box. So it was 4 over there. Small n is the number of chocolates to be selected, which is 2. Capital N is the total number of chocolates in the box. So it is small m into small n over capital N, which is nothing but 8 over 10 or 0.8. Any doubt in this?
So
Anyone?
how do we know that the number of chocolates, dark chocolates to be selected is 2?
See, 2 chocolates are drawn at random, right? So in general, I am selecting only 2 chocolates.
Yes, sir, but we could have 0, 1 or 2 dark chocolates.
Yeah.
So why are we only considering 2?
No, we are not. Small n is the number of chocolates to be selected. We need to select 2 chocolates, right? Not
Okay.
dark chocolates. Number of chocolates to be selected. That is 2, right?
Yes, sir.
Small m is number of dark chocolates in the box. We know that there are 4 dark chocolates in total, right?
Okay, sir, got it.
Clear everyone or any doubt?
Sir, M is
Yeah.
total with small
Yeah, I
m
think
is
we have interchanged it here.
capital M.
Okay.
Sir, if the
You
question
can,
was, sorry,
yeah, continue.
if the question was for white chocolates, then instead of 4, we'll be multiplying it with 6, correct?
Yeah. Then in that case, you are interested in white chocolates, right? So number of white chocolates in the box would be 6. So 2 into 6 upon 10, right?
Yeah. Thank you.
Okay, let's move further. So this kind of question, I think you have already done in today's session only. So see, the past records of football club in a golden goal matches are analyzed. Okay, and we have found out that the team will lose with the probability 0.4, and the random variable will take the value 0 if my team loses, and will take the value 1 if the team wins, and the chances of winning them is 60%, or probability is 0.6 of winning the golden goal matches. So what is the expected number of wins in 5 matches we have to compute? Okay, so see, our major concern is number of wins in 5 matches, right? So you can split it into 5 small random variables. X1 denote the result of first match, X2 denote the result of second match. Similarly, X5 denote the result of fifth match. Just try to think on it.
Sir, it's a Bernoulli random variable. It's taking only 2 probability.
Yeah, it is Bernoulli, but since we are doing week 10, I won't be using this term for today's session. So
Sir, Bernoulli is in week 10 only. Bernoulli.
The distribution is binomial because it has multiple Bernoulli trials.
Yeah, see, Bernoulli and binomial, you will get more clarity on this in week 11.
Okay.
Yeah, in general, yeah, you can say that it is Bernoulli, and number of wins in the 5 matches, that would become binomial. It would happen, but majority of you will understand it this thing clearly in week 11. So that's why I'm not switching to these terms for now. Okay.
Got it, sir.
So one question on considering this X. So here
Yeah.
it says X is 0 if the team loses and X is 1 if the team wins.
Yeah.
So so for winning and losing, is it mandatory that they should be 0 and 1 only?
Yeah, it's mentioned in the question, right? 0 if team loses and 1 if team wins.
Yes, yes. In one of the lecture, madam was saying that these are labels for winning and losing, and these labels could take any values.
Yeah, it could take any value, but in this question, these labels are given to you.
Okay, okay, got you.
When labels are not given, you can assume it to be any value. So it's up to you how you take it.
Got you. Since it is given, I should only be taking 0 and 1, not minus
Yeah.
1 and 1. Okay.
Yeah.
Yeah, thank you.
We're done with this, or you guys need more time to work on it? Anyone need more time, or shall we move to the solution part?
Done, sir.
Okay. Okay. So how did you guys approach this one? Anyone wants to explain?
So it is
Yeah.
the same event 5 times. Means
Correct.
even we have to give, means for even it is given that x equal to 1 if team wins and probability of team winning is 0.6. So if
Yeah.
we have to calculate wins in 5 matches, then px1 plus px2 to px5. It is 5 into p of x1. So
I multiplied 0.6 with 5
Yeah. Why did you do this? That's a correct approach, but why
because
are we doing this?
for winning
Yeah.
probability it is given 0.6. The number of matches are 5.
Sir, if I consider each match as a random variable, then we know by
Yeah.
that E of x1 plus x2 plus x3 is what we are calculating.
Yeah. Xi is the result of my ith match, right? And my first match, second match, third, fourth and fifth. So total number of victories I get is, I could write it like this, right? Suppose I get 5 wins. In that case, all my 5 random variables will take the value 1, right? If I get 0 wins, in that case, all will take the value 0. So in general, adding these 5, I can get my number of wins in 5 matches, right? Suppose if we get only 1 win, then it could be either 1 plus 0 plus 0 plus 0. Or another possibility is we have won in the second match and lose other. So all these possibilities are considered in these 5, right? So we can write number of wins in 5 matches as this. Because whenever it takes the value 1, it means we have won the match. So we can count the number of wins in the 5 matches as the number of ones we have in this 5 random variable, right? Is this thing clear or any doubt?
Yes, clear, sir.
Right. And for expectation, we know that each match is independent. So we can simply write it as sum of the 5. And
Sir,
we know,
if it is
yeah,
dependent, can't we write like that, sir? A summation.
independent also you can open the expectation like it, but for variance it won't open.
Yes, sir.
Okay, any doubt till this question, anyone?
Sir, instead of doing like this, in the question it mentioned that if the team wins, the 0.6 is the probability, right, sir? So
Right.
what I did is, so they are asking, the question is expected number of wins in 5 matches. So
Right.
I just took only one into 0.6, that is 0.6, 0.6 into 5. So
Yep.
3.
But why did you do 5 into 5?
Because there are 5 matches now. So the question is expected number of wins in 5 matches.
Yeah. So the multiplying
So
by
I
5, the
approached like
logic.
that only. I didn't do like this 0 into 0.4 plus 1 into 0.6 like that. I didn't
It's,
do.
yeah, but the actual way of thinking, it's this. You are getting the correct answer by that way,
Yeah.
but the actual approach behind that is this complete. Why we are doing like that, right?
Okay. So sometimes this approach might be wrong.
Yeah. Okay.
Okay, sir. That's what I want to ask. Okay, sir.
Okay. Anyone any doubt till this question, or shall we move further? Okay. So you all know what is variance and standard deviation of a random variable.
Yes, sir.
Yes.
Okay. It's the same thing as we studied in week 3, 4, but now we are doing the same in terms of random variable x. So expectation tells you about the mean value or the average values of the random variable, whereas variance gives the information about how much your values deviate from that average, right? So expectation of x is nothing but the mean of values of random variable x, and variance of x tells you about how much your values are deviating from that mean. Like earlier we used to compute the variance, standard deviation. It's the same thing, but this time in terms of random variables. Okay. Okay, so it's again the same question, but this time you have to find the what is the variance of number of wins in 5 matches. And notice that as yeah.
So, how expected value is mean of the random variable?
Expected value is the weighted mean in general. See.
Okay. Weighted. Okay. We are going for 1, 2,
Yeah.
3, 4.
We are taking into account the probability of that number as well, right? Okay, so here one thing to notice that the result of a match is independent of other match. So your random variable x1 would be independent of x2. These two will be independent of x3 and x4 and x5. These all 5 are independent random variables, right? You have to find what is the variance of number of wins in 5 matches.
Sir,
Yes.
hello. Sir, can I assume xi equal to xj for ith match and jth match?
Yeah, it's the same for each and every match, right? So it's up to you. You can assume all x1, x2, x3, x4, x5 are same.
So
Uh, Everyone able to solve this one? Or any doubt in this? Hello?
the question was solved, but I have a small problem.
But
I have one small question.
yeah,
Uh, expectation of expectation of x equal to x means, is it the same?
expectation of x. This thing you are saying?
Yes.
Yeah, the same as expectation of x. Because see, expectation of x, it's a constant value you get, right?
Yes.
And expectation of constant is nothing but constant, right? So it doesn't matter how many expectation you put, it would be still the same. Okay, so moving to this, this thing was clear, right? We can write number of wins in 5 matches as x1 plus x2 plus x3 plus x4 plus x5, right?
Yes, sir.
Now we need to compute the variance of number of wins in 5 matches, right? One important thing given in the question is the result of one match is independent of other. It means that all these 5 random variables are independent of each other, right?
Correct,
So
sir.
once we know that these 5 are independent, by using the property of variance, I can write it like this, right? And we know that each of these x1, x2, x3, x4, x5 takes value 0 with probability 0.4 and 1 with probability 0.6, right? So what would be the variance of xi? For that we need to compute expectation of xi square minus expectation of xi
Square.
whole square, right? So what is expectation of xi square? It is nothing but 0 square into 0.4 plus 1 square into 0.6, right? And expected value of xi, it would be 0 into 0.4 plus 1 into 0.6. So
0.6.
both are coming to be 0.6 only, right?
Hmm.
So your variance of xi would be nothing but 0.6 minus
Minus
point,
0.36.
yeah. So 0.6 minus 0.36, which is 0.24, right?
0.24. Yes, sir. That is
So
right.
E variance of each of these 5 random variable is 0.24. So it would be 0.24 plus 0.24 5 times, right? Which is nothing but 5 times 0.24, 1.2. Is this
So
clear?
again, multiplying with 5, sir, again. 0.24 is the variance.
Yeah.
Then again,
0.24 is the variance of each xi, x1, x2, x3, x4, x5.
Sir,
Yeah.
sir, I assumed xi equal to x1 equal to x2 equal to so on as x5. So
Yeah.
variance 5x equal to 25 variance of x.
5x equals to,
Variance of 5x equal to 5
yeah,
square into variance of x.
yeah, but here these 5 are not equal. These 5 are same PMF. That's all you know. You cannot do it 5 like that. It is x1 equals x2. It's not the case over here. You have to use the property of variance. You have to simply
So
split
sir,
it.
means if numbers are same, I cannot assume that
No, no, no.
xi
These
equal.
all, no. X1 is the result of first match. X2 is the result of second match. Both won't be the same in all the cases, right?
So I
In some
cannot
cases,
assume.
yeah, it is possible to get win here and lose here, right? So it won't always be the same. Unless and until the relation is given, you cannot assume any relations over here.
Sir, can you show me the question once?
Yeah. Any doubt in this, anyone? Or is it clear?
Sir,
Yeah.
X is the sum of 5 matches, is it? No?
Yeah. X1 plus X2. X1 is your result of first match, right? Random variable associated with the ith match.
Yes.
Right. So S, here we in solution we have written S. S is the number of matches won by the club in 5 matches. So it is just simply the sum of result of 5 matches, right? If you get a win, you will get an addition of 1. If you lose, you will get an addition of 0. So in general, you are getting number of wins in the 5 matches by adding all these 5, right?
Yes.
And we know that the result of match is independent of other matches as well.
Sir,
Yeah.
sir, the formula for variance of x is expectation of x square minus expectation of x whole square, no, sir?
Right.
Sir, while finding expectation of x square itself, I got 0.6 for one match, sir.
0.6, right?
Then I multiplied 0.6 by 5 and expectation of x whole square also for one match I got, which is 0.36, sir. That also I
Okay.
multiplied by 5 and then divided. Then I directly got 1.2, sir. I did not get
Yeah.
0.
Yeah, that's also you can approach. It's one and
That
the
is also
same thing
correct,
you're
sir.
doing. Yeah, that's also correct. Okay.
Thank you, sir.
Anyone any doubt in this one? Or shall we proceed further?
Got variance of 6.
Variance of?
6.
Variance of 6. I couldn't get your question. Can you elaborate a bit?
I can't understand where it made a mistake, but I got a variance of 6.
You got variance to be 6. Okay, how did you get 6?
Means I assume x to be events of 5 and square definition means x1 plus square. and so on.
Okay, let me write. Okay, so but you didn't, you have assumed a random variable x, right?
Yes.
And what does this x denote?
Number of wins.
Number of wins in 5 matches, right?
Yes.
Okay, then
Then I represented using some property x1 plus x2
okay,
till x5.
right?
Since now here one was given, means every match has the result of one if one.
Yeah.
So I just took it as a 5 into 1 and then squared it. So I got 25 x2.
No, but that you cannot do, right? Because your x1 will not always be equal to x2. It is also possible that you get win in the first match and lose in the second match. So your x1 will not always be equal to x2.
Okay.
Okay, you simply have to use the property of variance, that these are 5 independent random variables, right? So you can write it as individual sum of variance. It is nowhere mentioned that x1 equals x2, but yeah, variance of x1 is equal to variance of x2. We know expected value of x1 is also equal to expected value of x2, but x1 equal to x2 you cannot say, right? Even though their variance is equal, expected value is equal, this is also, but we cannot say that these two will take the same values. It is possible for them to have different values as well, right? Okay. Is it clear now, everyone? Or any doubt in this? Anyone, anything? Okay, then let's proceed to our last question for today. So let's assume your random variable y is a times capital S plus b, where capital S is another random variable and a and b are constant. So which of the following statements is true? You need to identify. Remember, capital S is a random variable, a and b are constant.
Sir, we have to write the options only, right?
Yeah, when you will click on answer question, you will see 4 or 5 options to answer from, right?
Sir, if two options are correct, then how can I put my answer?
In the options, have you seen the options given?
No, only the question in Join PD.
Yeah, but when you click on answer question, you will see the options as well, right?
There are option radio buttons for selecting 1 and 2, 2 and 3, 1 and 3.
Yeah. Just check out the options. You will be able to see. Okay, let's proceed to the solution part. Okay, yeah. So we know by the property of expectation and variance, right? Option 1 and 3 are correct. Whenever we multiply or add a constant, the expectation of expected value will get affected by the same manner. The constant get multiplied and the addition one will get added. While in variance, there is no effect of adding a constant, but when we multiply, it gets squared. So we will get a square times variance of s. Right? Any doubt in these slides, anyone?
Sir,
Yeah.
in week 9 content, sir, positive skewed and negative skewed is same as right skewed and left skewed.
Yeah.
So
It's the same.
positive means right skewed, right, sir?
Yeah. Positive is right and negative is left. Okay. Anyone, anything else?
No, sir, clear till now. Thank you.
Okay, then I think we can. Yeah.
The reference
will
book
you-
for to practice binomial problems.
It's mentioned in the portal, right?
I didn't check it. I will check so now.
Okay, sure.
Sir, I
When
have
will-
doubt in practice activity. Can I ask?
Yeah, sure.
I've got one question, quick one. When will you upload the slides? By today and tonight or
Yeah.
tomorrow?
Yeah, by tonight or maximum by tomorrow morning, not later than that. Okay. Okay, someone's having doubt in
Yes.
activity practice. Yeah, week 10, right?
Yes, sir. Week 10.
Okay, which question?
Practice activity.
Which activity question?
Practice assignment.
Practice assignment. Okay. Yeah.
Sir, I think question might be different. I will post in the chat.
Okay, sure.
Sir, I couldn't find it, sir, on the portal. It is under practice book, no, sir.
No, the reference books are mentioned over here, right? This one, Introductory
page.
Statistics by Sheldon Ambrose.
Okay, sir. Thank you, sir.
Okay, so the question you said is 4 fair coins are tossed.
Yes, sir. Sir, in this question, I see the explanation. In which they are doing 4 coin, making all the case of 4 coins headed till like this. And if we are do like this, if we toss a 1 coin and the tossing of coin is independent of each other, so we can add the probability. Then we can do that manner. That's my doubt.
See, you have to find the number of heads, right? It's same as the number of wins question we did, right?
Yes, sir.
I will add 1 if heads, I will add 0 if tails, right?
Yes, sir.
So number of heads in 4 tosses would be x1 plus x2 plus x3 plus x4, right?
Plus,
So,
yes, sir.
but we need to find the standard deviation, right? So what would be the variance of xi? For that, again, we need to compute this.
X square minus expectation of square.
Right. So what is the probability of getting heads? It's an
1/2.
it's unbiased coin, right? Given.
Yes, sir.
Okay, so 1/2, 1/2. So you can compute, will come out to be 1/2. Would be again this. So variance of xi would come out to be 1/4, right?
Sir, so if these are independent, we can add variance
Yeah.
also.
Yeah. Right. So it will be 4 times 1/4.
This is the case. We don't need to make all the cases. The explanation is given. We have making all the case, then finding the probability of 4.
Yeah, you can, but like making 16 cases, computing probability of each,
Yes,
very
sir.
lengthy, right?
Yes, sir. Yes, sir.
This approach is pretty simple to go with.
Okay. Sir, we can also assume that since it's not much in week 10, Bernoulli, it's also a Bernoulli random variable, so we can directly
Yeah.
apply the formula to there.
Yeah, each one is Bernoulli, and we add these independent Bernoulli, it becomes binomial, which you will study in week 11.
Okay, sir. Sir, one more question I have, I will post in the chat.
Okay, yeah, sure.
So for expectation, we don't require the events to be dependent or independent, right?
Yeah, but for variance, it needs to be independent.
So what if we have dependent events for variance?
In that case, the covariance things comes in. I think it is not covered in this course content, but yeah, you will cover it in stats too, mainly.
Okay.
Okay.
Thank you.
Okay, next question is this: Aditi has a rare disease, right?
Yes, sir.
Due to which she has to take injection every 3rd day. The cost of injection is ₹20. At X represent her weekly bill.
Yes, sir. Sir, I see the explanation, but I didn't get the probability, computing the probability part. It can, she can take injection in twice a week or thrice a week.
Yeah,
I
thrice a
I
week
also
and
went through
4 times a week, right?
3 times, sir. 3 times in a week.
3 times
But
in a
night
week and 4 times in a week is also possible, right?
Sir, 4 times, how it is possible? It's taking it every third.
Okay, every 3rd day. Yeah, so it would be 2 and 3, right?
Yes, sir.
Yes, sir.
This one.
But in the explanation, it mentioned 21 days, sir. That's it. That was confusing to me also, sir.
Sir, I didn't get the probability part. How we are computing the probability for?
Okay, Aditya's rare disease injection. Okay, so you understand this, right? Either she will take 3 injection per week or 2 injection per week, right?
Yes.
And if you notice the pattern carefully, first week, suppose starting from Monday.
Yes, sir.
In first week, she will take 3 injection.
Yes,
Then
sir.
in second, she will get 2. In third also, she will get 2. Right?
Sir, if it is the 4 case also possible, like she take every second day, so we have to consider 4 week or.
Why are they?
No.
They are taking only 3 weeks, sir. They didn't mention how many number of weeks here. They just
Yeah.
stay for a week. The 3rd day she has to take injection.
See, reason we are mentioning only this is because in week 1, right? You start from here, then you don't get injection, no injection, then you get injection, right?
Yeah, yeah.
0, 0, and then you get the injection. So in the week 1, you get 3 injection, right?
Yes, sir.
Okay. In second week, okay, now you have already got injection over here. So for 2 days, you won't get any, right? Then you will get, then again, you won't get any. Then again, you will
Sir,
get.
why are you moving to the next week, sir? They didn't mention the question, no, sir. They want weekly bill. That's all, sir.
Weekly bill. Okay, but we don't know for how many weeks will be taking injections, right?
Yes, sir. Yes, sir.
Yeah. Yeah. So for that also, okay, let's do this. So suppose if she had to take only for 1 week, it would be 3, right? For 2 weeks, it would be 3 in the first week, 2 in the second week. Okay. And for the third week, it would be again, now she cannot take in the first day, right? Because we need 2 days gap. She can take it over here. Then she can take it over here and then here. So again, 2 injection in week 3, right?
Yes, sir.
Now, if you notice carefully, from week 4 onwards, the same pattern will repeat.
The
In week
kids
4, week 5, week 6, right?
Okay.
So same pattern will keep on repeating. So in general, if you look, the probability of getting 3 injections in a week is 1/3, and for 2 injection it's 2/3, right?
Sir, how it's 1/3 or 2/3?
Because if there are 3 weeks in general, you will be taking 3 injection every one of the 3 weeks.
Because pattern is like this.
Yeah, pattern is like this. This
Okay.
pattern will keep on repeating for every 3 weeks, right?
Sir, but in exam, they will not give this pattern also. We have to generate a pattern.
Yeah, only this
So
question was given. We have generated pattern. Yeah.
yes, sir. Then we have to complete for 4th week, 5th week. So then only we are, come to know that the pattern is same for the above continuous
Yeah.
weeks.
Yeah.
So this is the way we have to do. Okay, sir.
So can you please take the different example, like every 4th day, how we compute the probability in that case for understanding?
Every 4th day. Okay, so we will have to. Okay, let's try. So we take over here, right? Then we cannot take for the next 3 days, right?
Yes, sir.
Then we 1, 2, 3, 4, 5, 6, 7. Okay, then we will take it over here, right?
Yes, sir.
Then we cannot take it for 2 days. So in week 1 there are only 2 injections, right?
Yes, sir.
Okay, in the second week we cannot take for first 2 days. Then we can take it over here. Then again,
So
no
first
injection
one
for
day.
3 days.
First 1 day.
First 1 day, which one?
Sir, it's in the second week, it's 0, 1, sir.
0, 1, yes. Sir.
Okay. Okay, so we cannot. Okay, we can take it over here. Then not for next 3 days. Then over here. Then it will go like that, I think, right? So again, it would be. So if you see here, after 4 weeks, the pattern is repeating, right?
Yes, sir.
And values that it can take is.
Only
Okay, so yeah, you take 2 injections with probability 3/4 and 1 injection in a week with probability 1/4, right?
Okay, sir.
So this pattern you need to identify.
Okay, sir. Got it.
Sir, in general, can we form an algorithm that number of injections means number of gap will determine the number of pattern?
Yeah.
Because if they are asked every 3rd day, then three rows are generated.
Yeah.
And for every 4th week, 4 rows. So if they are asking for every or second
That's
day,
what. Yeah, that's what you can check. But it could be a possible pattern. But you can check.
Sir, can you explain that 1/4 again, sir? 2/3 I understood, but week 1, 1/4, right? And week 2, 2/3. So can you explain the 1/4 one?
1/4 is C. If you notice that this pattern is repeating every 4 weeks, right?
No, sir, the previous one, previous question, sir. The previous that table, sir.
Okay, this one, right?
Yeah, this one.
So if you notice over here, on every 3 weeks, there will be 1 week where you will take 3 injection and 2 weeks where you will take 2 injections, right?
Yes, sir.
So if you notice in general, out of every 3 weeks, 2 weeks you need to take 2 injections. So probability that you will take 2 injection is 2/3 in general, right?
2/3, yes.
And of every 3 weeks, there will be only 1 week when you will be taking 3 injections. So probability that you take 3 injection is 1/3, right? So the cost for 3 injection is 60 and 2 injection is 40. So that's what the random variable X is denoting over here.
Correct, sir.
Sir, every 3 days means
Every 3 weeks.
No, sir, in question it's saying every 3 days.
Yeah, every 3rd day she needs to take an
Every 3rd day.
injection. So we
in
are
between two can be gap, sir. 0th day, first day, second day, third day.
yeah, first day we have taken, then for second and third day we won't take. On fourth day we will take.
Okay.
Every third day. Okay. Anyone, any other doubt? Or shall we close for today? Okay, guys. Thank you, everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.